Yes, good evening, guys.
Good evening, sir.
I'm audible.
Good evening, sir.
Yes, sir. Good evening, sir.
Okay, so we'll start with a new topic that is your starting and reversing. So, can somebody explain me how does your engine starts? Anyone? How does your engine starts? What is happening? How does your engine start? Or your bike engine, or your car engine, or the engine on the ship, or your generators? Okay, how they are starting?
Sir, cranking, sir.
Cranking. Okay, you will crank it. That means the engine piston is moving up and down. Then what?
Then fuel is delivered,
All right.
and along with other fuel air mixture will be delivered due to the compression or the spark plug or whatever we have to combust fuel, and with that energy will be produced, and further there the flywheel is there, and it will be used for other what is it for other cycles.
All right. So how engine starts? So first of all, cranking. Okay. So for example, if I take a generator, okay, so you have a starting air motor. Agreed? Everyone knows about it, right? Starting air motor is there. As soon as you press the button, the starting air motor will get energized and it will rotate your flywheel. And if the flywheel will rotate, what is going to rotate? The pistons will rotate inside my what do you say, liners. Agreed?
Yes, sir.
And when the pistons are rotating inside the liners, what they will deliver? They will deliver your compression, pressure, and compression temperature, right? Okay, so this is what it is going to build up when you're cranking the engine. Agreed? You take any engine, okay? You take bike engine, car engine, or your main engine, or your auxiliary engine. Everything you have to give, first inertia to your pistons, right? The pistons will rotate. After only that, you will be getting your what do you say compression pressure and compression temperature. Isn't it? So by the end of the compression, the temperature, okay, is around 520 to 550 degrees Celsius. Approximately this much temperature is being generated only when your air is getting compressed inside your engine. Okay. Now you all know, like for petrol engines, I need a spark plug, and for diesel engine, I don't need a spark plug, right?
Yes, sir.
Petrol engine, spark plugs are provided.
सर बहुत पढ़ा दिया क्या आपने कुछ एक्स्ट्रा सर वो मेरा थोड़ा मिस हो गया थोड़ा स्टार्टिंग में
So no, not just started up. For diesel, I'll repeat again, no problem. Diesel engine, no need of spark plugs. Okay. What we have discussed till now is how your engine is getting started. So first of all, you have to give initial inertia to your pistons and all, right? So for that,
यस
you have starting air motors, like in your generators, in your diesel engines, like your main engine. If you say, then you are starting it for with starting air
यस सर
you are admitting, right?
यस सर
Direct air engine.
यस हाँ
Okay.
सर यस ओवर द
In
पिस्टन यस सर
generator, there is a starting air motor. Similarly, in your cars and all, also they have motors. They will engage with your flywheel and they will turn your flywheel. Okay. So when the flywheel is turned, your piston is going up. Okay.
यस
Piston is
सर
moving inside the liners. And if piston moving inside the liner, it will develop some compression pressure and compression temperature. Agreed?
यस सर यस सर
Okay. So when this compression temperature is developed, so by the end of the compression, the temperature is around 520 to 550 degrees Celsius. Okay, this much is
यस
your
सर
temperature at the end of the compression. Now we discuss, like in petrol engines, we will be needing spark plugs. In diesel engines, we don't need any spark plug. Why? But why? The reason for it is diesel engines, okay, or diesel flash point is high, okay. It is around 85 degrees Celsius, okay, flash point, okay. But the auto ignition temperature is low, okay. It is around, auto ignition temperature is around 500 degrees Celsius. So in diesel, if my the fuel which is diesel right now, if its auto ignition temperature is 500 degrees Celsius, isn't it lying between this part? Whatever temperature I'm getting at end of the compression, is it lying in
Sir,
between this?
so you have written
Yes,
auto ignition temperature is low,
Yes.
and you have written
compared to
500.
petrol.
Don't worry, I will come to that. Okay. Compare it. I'm comparing it with petrol. Okay. That's why
Okay,
I'm
okay,
writing low.
okay.
Okay. So it is obviously less than what I've generated already at the end of the compression.
Yes,
So
sir.
will the fuel ignite by itself?
Yes, sir.
Tell me.
Yes, sir.
Yes. I don't need a spark plug there, isn't it? For
Mm.
petrol engines or petrol, when we are using petrol, okay, the flash point is as low as 0 degrees Celsius.
60.
Okay. You can take different type of diesel MGO, you have MDO. Okay, so you have different petrols. Okay, so I've taken one specific one and I've given you around 0 degrees Celsius. Okay, it will give vapors even at 0 degrees Celsius, but the auto ignition temperature is high, is more than 600. So now this is not lying in between this phase, what I'm generating at the end of compression. Agreed?
Yes, sir.
That is why in petrol engines you will be requiring spark plug. Okay, so spark plug is kind of what? There will be two electrodes
Heat,
2 electrodes, sir. Yes.
high voltage.
and there will be a high voltage current flowing between them. It will ionize the air and a current will flow through them and it will be a very high temperature. And because of this high temperature, your fuel will is going to ignite. Is it clear?
Yes, sir.
Okay, like what we are doing in your what do you say, boilers, right?
Yes, sir.
All right. Now, what are the different starting methods we have? So we do have hand crank engines. You might have seen in weddings and all, you have a small generator, they will crank it by hand and then there's a decompression lever on top of it that they will use to start it. Okay. So hand crank engines are there. Then you have electric battery start. Then you have hydraulic start. Then you have air motor start. These all the are cranking mechanisms, right? Air motor. Then you have spring start or also known as inertia start. Then you have finally the direct air injection. Now our main engine is very huge engine, right? We cannot put a starting air motor over there. Okay, so a lot of force will be required, a lot of torque will be required by the starting air motor to turn such a big engine, isn't it? That's why we are not going over there for air motor start, and we are using direct air injection for what purpose? For starting main engine. When the air will be introduced on top of your piston,
Piston.
it will give inertia to your piston. Okay, your piston
Yes,
will
sir.
start rotating inside your liners. Okay, and that
Yes,
is
sir.
how they are generating your compression pressure over there. Okay, and compression temperature. Now, hand crank engines on small generators. Okay, not used on board. Okay, small generators. Even your lifeboat engine's second means of starting can be a hand crank engine. Okay,
सर इमरजेंसी कंप्रेसर था हैंड क्रैंक
lifeboat engine. I've not seen emergency compressor hand crank one, but it was there on your ship.
यस सर छोटा सा था डीजल
Emergency compressor. Okay.
Sir, sometimes the emergency fire pump can also be hand crank.
For that, there will be a generator only, right? Or engine has to be there, right? That's why it will run. So electric battery start is your emergency diesel generator.
Yes, sir.
Okay. You have lifeboat engines, life raft engines. Okay. These all are your what? Electric battery start. Okay. So
Yes,
you
sir.
will be having a series wound rotor. Okay. Wound DC motor is there that is going to engage with your flywheel of your engine, and it will turn your flywheel. And when flywheel turns, your piston is moving inside, up and down. Okay. And because of it, pressure is being generated. Okay. And temperature is being generated. Then hydraulic start is also
EDG.
given in your MNC diesel generators. Okay. So second means of start. Air motor start is normally your auxiliary engines.
Generator.
Okay.
Yes, sir.
Auxiliary engines can also be direct air injection also. Okay. Some auxiliary engine can also be those who have sailed on container ships. They might understand that. Okay. Because a bigger generator will require a lot of force, and that then they are supplying this direct air injection also in your auxiliary engine.
Sir,
Mostly air motors. Yes. Bolo.
sir, you said that auxiliary engines are in container ships. It's a direct injection, like air
No,
injection.
not all. Not all. Okay. Not
Depends
all.
upon the cylinders. Less than six
Yes.
cylinders, then we can use this air motor. If it is more, then we can use the direct air injection method, right?
Correct. Okay. I will come to that. Okay. Spring and inertia start is also sometimes given for emergency diesel generator. Okay. Second means of starting other than your battery starter. So what is we are going to focus here is basically your direct air injection. Okay. This is what is we have to understand. And by this, we will understand the other concepts also. Okay. So far, so clear? Everything is clear till now?
Yes, sir.
Okay. So for direct air injection, if I have to give a direct air injection, there is a regulation. If direct air injection is there, it has to have a cylinder head relief valve. Okay. Cylinder head relief valve is must in case of direct air injection. Okay. It doesn't mean if direct air other means you are doing, then relief valve is not provided, it is provided. But in case cylinder head relief valve is there, like if I talk about your car engines, is there any cylinder head relief valves there?
No, sir.
Yeah. So it is must in case of direct air injection. Okay. You cannot exclude it. Why it is must? Because during the starting period of time, because during starting, a very large amount of air is introduced.
सर मेरा नेटवर्क थोड़ा चला गया था. So what is direct air injection?
Wait. Amount of air is what I was saying is, in case of direct air injection method, cylinder head relief valves are must. Okay, you cannot bypass them. You cannot not give them on the engine. It has to be given if in case your cylinder head direct air injection technique has been taken up for the engine. Okay. Now there's a very interesting question with regard to this. That is, suppose I have two pistons, or I'm taking two cylinders, okay, and in the cylinders I have these two pistons. So for injecting this air, there will be starting air wall, air starting wall,
Yes, sir.
Yes,
huh?
sir.
Which will be injecting how much bar pressure?
30.
30 bars, sir.
30 bar, okay. 30 bar of pressure is getting, and it is getting injected on top of my piston. This is what my pushing my piston down, agreed?
Yes,
Yes,
sir.
sir.
But somewhere else on the other unit, the piston might be coming up,
Yes, sir.
okay. This is going down, this is coming up, okay. I'll take, hold on, दोनों same position पे बना रही है. This piston might be going up, right? One piston is going down, so other piston somewhere, some unit piston is might be going up. And at the end of the compression, how much approximately pressure it is getting generated?
300 to 400.
300 to 400 compression pressure I'm asking.
अच्छा सर.
Around 80 to 90 bar of compression pressure is
sir.
being generated. Okay.
हाँ sir.
Okay. Now this 30 bar is there. Okay. It is acting on top of my piston, which is trying to move my piston down. But my end of the compression, I have 80 bar or 90 bar. How is it possible that this 30 bar can push this piston down, irrespective of this 80 bar, 90 bar acting on top of my piston? It will not allow 30 bar to go down, right? 80 bar is
Yes,
more.
sir.
So what could be the reason? Now,
Due
to
to
understand
momentum
this,
of flywheel.
now to understand this concept, we have to understand the force acting on the piston. Okay, let me take this force as F1. Okay, and on the piston here, the force is acting F2. Okay, so force equals to
Mass into area.
Pressure upon.
Or pressure into area.
okay. What is the pressure here in case of first unit here? This is first and this second. Okay, so pressure is 30 bar. Agreed.
Area will be same.
Area will be the area of the piston. Agreed. That will be
Yes, sir.
same in both the cases. So this is
Yes,
the
sir.
average pressure I have taken. Okay, average pressure. You can take it as 28 maybe. Okay, 28 bar. Okay, or 30 bar, whatever you want to take. Okay, normally it is slightly less than 30 bar only. Okay, so practically. Now, when we consider the second piston now, so force here is F1, F2. It is also equals to P2 into area. Area will be same, right?
Yes, sir.
Now, is the 80 bar pressure being generated here itself when the piston is over here?
No, sir.
Okay. When the piston is exactly at TDC, that is the point when this 80 bar is getting generated.
Yes, sir.
Yes.
So if I'm going to take the mean value of this, don't you think this 80 bar has to come down? If I take the mean, suppose here it was 2 bar, 4 bar, 5 bar, 6 bar, 10 bar, 50 bar, like this, it is increasing, isn't it? So I have to take a mean
Yes, sir.
value. Okay. If I take the mean value of this peak of pressure, we can also say it as a compression pressure. Okay. So this will, if I take the mean of this, all these values, then it will come approximately 10 to 12 bar of pressure. Okay. P2. So will the F1 be greater than my F2 force?
Yes, sir.
Agreed. Because area is same. Now you see here the pressure is acting as 28 bar. Here the pressure is acting 10 bar. So I am able to turn my engine. And as soon as this pressure is being generated, it is has come to TDC, the air starting valve will again open to push it further down. Agreed?
Yes, sir.
Okay.
सर एक बार
Excuse me,
और
sir.
रिपीट कर दीजिए.
Yes.
So 80 to 90 bar pressure कब हो रहा है?
At the end of the compression, right?
When it is coming to the TDC.
Yes. But right now the piston is at bottom, right? So the pressure is not acting 80 to 90 bar at this point, isn't it?
Yes, sir.
At every stage when the piston is moving up every centimeter or so, your pressure keeps on increasing gradually.
Yes, sir.
So I have to take a mean value. Here I don't have to take mean value because it is injected almost at TDC, isn't it? Actually, little bit after TDC. Okay. So I
5
have to
TDC.
take, yeah. So it is actually in man BW. In man BW, the air starting valve opens. So it opens around 10 to 11 degrees after TDC
TDC.
and closes 110 degree after TDC.
So
Okay.
before TDC, sir.
Sorry. Before TDC. Before TDC कैसे बंद होगा? After TDC ना?
नहीं सर,
Air
ये
starting
valve open, sir.
opening, sir.
No. It is will be 11 degree. Now for Sulzer, it opens 4 degree before TDC and closes 102 degree after TDC. Okay. This is the air starting valve opening times. Okay. But now what we are going to use to understand one thing like about how many units we require to actually use a air starting valve and all those things. Okay. In that, I will take this starting as 0. Okay. I will take this starting as 0. Now, this is actual opening of this thing, right? This is actual opening of the valve, 11 degree after TDC. Because you understand one thing, in air starting valve, you have a spring. Okay. You have a very hard spring. And when
Yes,
you are
sir.
going to inject air, this spring will also resist.
Yes, sir.
Okay, so it does not exactly opens just before TDC or after TDC. It completely opens around 11 degree after TDC. Is it clear? Completely opens at 11 degree after TDC. Because valve will take some time to open. Agreed?
सर एक बार वो ऊपर जो आपने बोला कि 70-80 बार है, वो कैसे मीन प्रेशर आपने मुझे एक बार और बता दीजिएगा प्लीज.
Yes. Let me draw one simple diagram regarding your air starting valve. Okay. So air starting valve, then you will understand this. The air starting valve of man BW will look like this. Okay. This diagrams you can draw even in your riddles. Okay. Then you have a this wall is coming down. This. So this is a diagram of your air starting valve for man BW. Okay.
Excuse me, sir.
Yes.
तो आपका पायलट है 30 बार रहता है?
Yes.
सर आने का टाइम 7 बार होता है अकॉर्डिंग टू द एरिया इट गोइंग टू इंक्रीज द प्रेशर राइट.
No, will be 30 bar.
This is starting air wall.
The control mechanism is from 7 bar, but when the pilot air will come, it will come 30 bar only. Okay, you will come to know later in this class itself. Okay.
जी जी.
Okay. So this is the actuating mechanism wherever this air is going. Suppose you have multiple air starting walls, right? Suppose 8 units you have, then eight walls will be there, isn't it? Every unit will
Yes,
have
sir.
its own starting air wall. So
Yes, sir.
whichever unit this air will be going, this will be available. This starting air will be available for all the units. All the units. But this 30 bar cannot open right now, this valve. Okay, it cannot open. All right, until the 30 bar comes from top also. Okay, when this 30 bar will come, it will act on the larger area. Agreed. So force acting over here will be pressure into area. Area is large, so the
Yes,
force,
sir.
what it will do, it will push my piston down, main piston. This is the main piston. Okay, this is a spring, a hard spring. Okay, so when this 30 bar air will come, it will push my main piston down and compressing the spring. So at that time, spring will also exert some force back on top, isn't it?
Yes, sir.
You will, as soon as you start compressing the spring, it will start, exerting
Repelling.
a pressure back to your face, isn't it? Okay, so
Yes, sir.
that is why we never consider like it is that is why we consider when actually the wall is completely open because of the spring inertia and all, the wall opens around 11 degree after TDC completely. Okay, is it understood? Follow guys.
Yes sir.
All right.
सर ये बैलेंसिंग पिस्टन मतलब फिक्स रहता है कि इट इज moving along with the spindle of the valve?
No, it is fixed.
It's fixed to the
Now,
valve to
now,
the body only.
hold on. Now you understand one thing. If this balancing piston is not there, don't you think this 30 bar air will go up, acting on the bottom face?
Yes sir, yes sir.
Okay. So will
Hmm.
your valve open? The valve will
Yes.
not open,
No,
right?
no, no, no,
So
no.
yeah.
It will not
So
open.
that is why this balancing piston is provided over here in order to stop this main starting air which is coming from the 30 bar. Okay. Now you might have seen this is a very big line, starting air line jo aata hai. Agreed?
हाँ सर.
But this is a very small diameter pipeline. Okay, maybe of a diameter of 2 fingers and all. Okay, it is only for actuating purpose. Okay, for which unit air will be given. For ME engines and all, there will be one solenoid valve. Okay, this is coming from the distributor. This air is coming from distributor. But in ME engine, I don't have a distributor. I don't have a cam and all those things. I have a solenoid valve. Whichever solenoid valve is open, that 30 bar air will be gone and your engine will be started. Okay. So
Hmm.
this is the normal picture for your air starting valve. So this diagram is understood to everyone. Bolo? Is the
Yes
figure
sir.
understood to everyone? Okay.
Sir.
Now we will try to understand like suppose I have a 3 unit engine.
सर वो एक पार्टन सर वो जो ऊपर से 30 बार वो एक्ट कर रहा है लाइक
Yeah.
इट इज व्हाई इज इट एक्टिंग लाइक सर जब मतलब वो एक फ्रंट से भी अपना 30 बार वो एक्ट कर रहा है सर वो थोड़ा सा नहीं समझ
नहीं मैं समझा नहीं फिर से एक बार बोलो.
वो आपने जो अभी ऊपर समझाया सर वो एयर स्टार्टिंग वॉल का अरेंजमेंट सर वो ऊपर से भी 30 बार आ रहा है सर जो
Yes.
अगेंस्ट द स्प्रिंग उसको कंप्रेस करेगा सर
Yes.
और वो इधर से भी सर ये 30 बार स्टार्टिंग एयर सर ये अंदर आ रहा है सर ये
Okay.
सो आई
Hold
नीड
on.
बी लाइक
I don't want to jump first of all, but still I'll give you a slight idea. So this is the diagram of how the air is flowing into your system. Okay, starting ka diagram here. Okay. You can see the 7-bar air is this one. It is, I will use maybe red color. This is the 7-bar air coming. Okay. And it is acting on my auto starting valve. It will activate auto starting valve. Then the main air total 30-bar air will be going. Okay, this 7-bar is also going over here. It is acting on my distributor. This is my distributor. Okay, so it will push it down. This piston will be pushed downwards. Right now it is blocked. So this 30-bar air, which is in my starting air manifold, will also come here. What is written over here?
Pilot,
pilot valve.
pilot
So
valve.
this is pilot air. This air will go like this, and then it will go and start acting on top of my air starting valve. Okay. From the other side, starting air manifold, the 30-bar is already present on all of the units, but only 1 or 2 units maybe will be going this air, pilot air, and only that units, your air starting valve will be open. Okay, understood?
सही ये बाद में समझाओगे ना फिर?
Yes, yes, I will come, but
हाँ.
now you asked before, so I
Mhm.
start. Okay, now we will discuss about, suppose we have a 3-unit engine. Okay, एक फंडा आपको समझाना पड़ेगा. Like how many units actually you need to actually have a direct air injection. Okay, suppose you have a 3-unit engine and it is a 2-stroke engine. Okay, that means the main engine. Okay, and you have 3 units. So if I draw a circle, okay,
सर वो ऊपर वाला एग्जांपल भी बता दीजिए, वो समझा नहीं
well,
करना. 80-90 बार वाला.
okay, I'll come
सर पहले
afterwards.
समझाया था.
आता हूँ, बाद में आता हूँ, ठीक है.
Yes, sir.
ओके सर.
And if I have 3 units, that means all units के बीच में डिफरेंस कितना रहेगा?
120 degree.
120
This will be 120, 120, and 120, right? So this is suppose number 1 unit, number 2 unit, and number 3 unit. Okay. Now, why do I have to stop the air injection at 110 degrees here? Why I have to do that? What is happening after that?
So maybe compression pressure and temperature, compression temperature
After
is achieved.
110 degree after TDC, your exhaust valve opens. Suppose this is your piston, this is your air starting valve, okay, and this is the exhaust valve, right? Main engine ka exhaust valve. Not until 110 degrees, suppose at 110 degrees, your piston has reached over here. Your air starting valve should close. That means the pilot air which is coming on top will stop. Okay, will stop coming, and the spring pressure will close your valve back. Okay, why? Because after that your exhaust valve is going to open, right? If I'm keep injecting my air, don't you think the air will leak out from the exhaust valve?
Yes, sir.
Yes, sir.
Okay, so there will be wastage. So that means before my exhaust valve opens, I have to close my starting air valve.
Hmm.
So if somebody asks you why we are stopping at 110 degree, can you give the answer? Bolo?
Yes,
Will you
Yes,
be able
yes,
to
sir.
answer?
yes,
All
sir.
right. So normally now if I have taken 3 units and I will use the starting air manifold or starting air ball, I will use here to explain you why I need at least 4 units to start the engine from any given state. So normally we consider, suppose we start from 0 degree. Suppose this is a 0 degree. And my number one unit air starting valve opens here. Till how much degree it will go?
110.
110.
Suppose this angle is my 110. So here somewhere my number one unit air starting valve will close. Agreed? Agreed?
Yes, sir.
Okay. So number two will start from here. It will again 110 degree afterwards.
Hmm.
Yeah, this is 110 degree. Number 2, air starting valve open. Here, 2, air starting valve close. Then number 3 will start from this position. Agreed?
Yes, sir.
Yes, sir.
Air starting valve open, and it will go till 110 degree after its TDC, and that will be number 3, air starting valve opens. Now, this region over here, can you see this yellow color, right? Or should I change the
Yes,
color?
sir.
So
नहीं
the
दिख रहा है सर.
close होगा sir.
So, this part, can I say in this part, how much degree it will be first of all?
10 degrees.
Okay. So, at this part, is there any starting air wall open?
No, sir.
You take this example here. Number 1 has closed over here. Number 2 is opening over here. Agreed? So, at this
Yes, sir.
duration, there is no or any of the yellow colored region, there is no air starting valve opens. Agreed?
Yes.
So I can consider this as my flywheel, suppose. Okay. And these are the degrees in the flywheel. Okay. And suppose my flywheel has stopped in a region. Suppose like this is a flywheel. You have seen the flywheel, you have all this given over there 10 degree, number 1 TDC,
Yes,
number 2
sir.
TDC. All these markings have been given. Suppose there's a pointer over here on the flywheel, and this region is coming exactly in this shaded region. So if in this case I give direct air injection, will my engine start?
No, sir.
Because air will not even go to any of the engine. What I have to do, I have to engage my turning gear. I have to turn my engine until the pointer comes somewhere here. Agreed? If the pointer was here, then no air was getting injected in this part. Agreed?
Yes, sir.
Okay. But if I have to turn this engine, I have to engage by turning gear, and I have to turn the engine slightly so that it comes to the this shaded part, what I have shaded with yellow color. Okay. So that means in this particular complete range, at least my number 3 is open, right?
Yes, sir.
Okay. So engine can start. But if it stops in this yellow color shaded region, the engine cannot start. Agreed?
Yes, sir.
Yes, sir.
That is why a 3-unit engine cannot be used as or used for direct air injection. Is it clear?
Yes, sir.
Okay. Now we will take example of 4 units. Suppose I will draw a diagram for 4 units. So 4 units, that means every unit will be 90 degree.
90 degrees.
Yes, sir.
Suppose this is number 1, number 2, number 3, number 4. So air starting valve will open number 1 here and close 110 degree. Agreed?
After
This
TDC.
is
Yes.
90. Agreed? This is 90. So this will be 110.
Yes, sir.
Okay. Number 1, air starting valve.
Close. Close. Okay.
A starting valve open. Okay, number 1, A starting valve
Close.
close.
Huh.
Okay.
Yes, sir.
And here, air starting valve open. And my number 2 is starting here. Agreed? Air starting valve open. Where it will stop? Somewhere here.
Yes, sir.
Number 2, air starting valve close. Okay. Then number 3 will start from here and stop somewhere here. Number 3, air starting valve close. Similarly, number 4 will start from here and stop here. Yeah, starting. Yes. Starting now. Let's start. Okay. So now you take any point. Okay. Let us say this shaded region I will take. In the shaded regions, how many units are getting here?
4.
Tell me guys, how many units are getting here?
4.
4 in the shaded region.
2, sir.
So at least 2 units are getting here. See, in this part, if I take one of the shaded region, this one, so number 4 is starting from here. Agreed? So in
Yes,
this
sir.
part, number 4 is injecting air, but number 3 unit has not still closed. Agreed? At
Yes,
this
sir.
part, number 3 still is not closed. It will close somewhere here at this point. So here I am getting 3 and 4 units are getting air.
Yes, sir.
If I consider this part over here, which unit is getting air here?
Only 3.
Number 3. So that means the
3 is
complete
getting 2,
revolution,
sir.
all the units are getting air at any given point of time. If my flywheel stops at any given position, I can start my engine with my air. I don't
Yes,
have to
sir.
manually turn my engine. Agreed?
Agreed, sir.
Okay. So this shaded region, what is present over here, this is known as
Overlap.
air starting valve overlap.
सर एक बार फिर से बता दिए प्लीज.
Yes. So when I increase the number of units, and if I draw the diagram of my air starting valve when it is opening and when it's closing, so the shaded region that I've drawn here, okay, the diagram is understood, right? How I've drawn?
Yes, sir.
हाँ सर वो समझ रहा हूँ.
Okay. So now at any given position, at least one of the starting air valve is active. कोई भी position ले लो आप इसमें, ठीक है? You take this position, uh, you take this position here. My number 1 is active. Agreed?
हाँ सर.
You take this position here. My number 2 is active.
Yes, sir.
You take this position here. Number 3 is active.
Yes, sir.
At this position, number 4 is active.
Yes, sir.
Now you take the shaded regions. Here, number
Number
1
4.
and number 4 both are active.
हाँ
Agreed?
सर.
You take other ones also. You see everywhere at
Number 1.
least 2 in the shaded part. At least 2 air starting valve is open.
Yes, sir.
Okay. So when more than one starting air valve is active, okay, that is known as overlap of the starting air
Overlapping.
manifold.
Yes,
Okay.
sir.
And how much degree it will be? Calculate.
10 degree.
20 degree.
20 degree.
20.
110 minus 90, right?
Yes,
हाँ
sir.
सर.
Okay. So at least 20 degree of overlap period I am having. Okay. That means I can start my engine no matter what, at what condition it has stopped, what point it has stopped. If I start my engine, my air will turn my piston. Agreed? But that was not in the case of my 3 units. In this part, the shaded region was not getting air. Agreed? Hello guys, is it
हाँ
clear?
सर.
So for direct air injection, at least how many units are required?
4
4.
units.
These questions are asked in orals. Huh? At least 4 units are required. Okay, they will ask you about overlap, starting air valve overlap. Then you have to say if more than one unit air starting valve is open at any given point, that is known as overlap of the starting air valve. Is it clear?
Yes, sir.
Okay, when more than one unit is getting air during the starting, that is known as overlap of the starting air valve. Now, there's a formula also for it. Okay, so formula is, they ask the formula also, overlap equals to positive starting angle minus 360 divided the number of units. Now this is for two stroke. Okay, this is formula for the two stroke part. So what is my positive angle of starting?
11 degree.
For in this case, I'm taking suppose I am using number of units is 4. Okay, so 110 पे बंद कर रहा हूँ ना,
20.
Yes, sir.
110 पे I'm stopping it, right?
Yes, sir.
Minus 360 divided by number of unit is how much? 4. कितना आ गया overlap?
20.
20 degrees. Okay, now if I increase number of units, suppose I increase the number of units to let us say 6. 100 minus 60, how much overlap will be coming?
50 degree.
Okay, so as you increase the number of units, you understood that overlap is also increasing. Agreed?
Yes, sir.
Okay, more the overlap, better your engine will start, at any given point. Okay, jitna overlap rahega, that is good for your engine. Now, let us take an example. For your 4-stroke, I also give you something. For two stroke, minimum 4 units are required for direct air injection. Is it clear? This we have discussed, right?
Sir,
For 4,
more
yes,
degree of overlap, that means more starting air valve is open.
yes. More degree of overlap means for a particular, for this 50-degree part, at least 2 starting air valves will be giving air.
Okay.
Okay, and if 2 units are getting air, your engine will turn faster.
Faster, yes, sir.
Right? So engine starting will be much easier. Okay.
Which is
Now for 4-stroke, minimum numbers of unit that is required. Minimum 4 units are required. Minimum here 6 units are required. Why? Because now it will be in 2 revolution. This will become 720. Okay. And for positive angle, the positive angle for 4-stroke is in the range of around 130 to 135. Okay, for 4-stroke engines. And if you calculate, you will be able to understand how much your this thing will be. Okay, how much will be your overlay. Is it clear? So that is why if a generator is less than 6 units, okay, if it is less than 6 units, you might have seen 4 units, 3 units generator, okay, 5 units generator. So those generators can never be direct air injection. They will always be air starting motor start, because air starting motor ko to no lafda is there na for this thing overlapping.
Yes.
It just has to turn your what do you say, flywheel. Agreed?
Flywheel, sir. Yes, sir.
Yeah. So if the engine generator is more than 6 units and 6 units, then only a direct air injection is possible. Otherwise, we have to go for air motor start. Is it clear? Bolo.
Yes, sir.
Okay. Can I
सर
move further?
ओवरलैप का डेफिनेशन एक बार बता दो ओवरलैप का
Overlap is if when more than 1 unit is getting air during starting, then that is known as overlap of starting air valve. I'll write it down. When more than 1 unit is getting starting air, or you can say if more than 1 unit air starting valve is open, okay, getting starting air, until starting of engine. That is known as air starting valve. Okay. And please note the formula from the top. Okay, positive starting angle minus 360 divided by number of units. Okay, this formula also sometimes they are asking in returns. Okay, just give me a minute. I'm doing some.
भाई नोएडा एमडी से है जो, तो क्वेश्चन शेयर कर दो यार, पूछ लेंगे सर से इस टॉपिक पे।
Okay, guys, बोलो पहले का कुछ समझ नहीं आया क्या जो बताना है दोबारा से?
हाँ सर, वो पहले मेरा ये वाला जो एग्जांपल दिए थे ना 80-90 वाला, वो बता
दिस इज
दीजिए।
अंडरस्टूड 3 and 4 units वाला.
यस सर।
सर एक बार
Yeah.
3 यूनिट्स वाला एक बार बस हल्का सा रिपीट कर दीजिएगा सर। इसी अभी कर
3 units
दीजिए सर,
में
कोई
क्या
बात
है
नहीं।
that all units if complete circle is a 360 part. Okay, consider your flywheel. So in two stroke, in one revolution all the strokes are happening.
यस सर।
Okay, so I have to take only 360 part, right? So if I have only
यस
three
सर।
units and if I divide that 360 into 3 degree, 3 units,
वन
how
ट्वेंटी
how much it will be? 120
वन
degree
ट्वेंटी
apart, right?
हाँ जी सर, हाँ जी।
Now I explained you like why I need to stop my air starting wall at 110. What
हाँ
reason
सर,
did I
एग्जॉस्ट
give?
वॉल्व लिफ्ट अप हो जाता है। हाँ,
Because
एग्जॉस्ट
exhaust
वॉल्व
valve is
लिफ्ट अप हो
going to
जाता
open after that, right?
है। यस सर।
So if my air starting wall, suppose, has opened here exactly at 0 degree, for example, so it will stop somewhere around here, 110 degree afterwards.
यस सर।
Okay, but my second will start from here, na, 120
यस
degree
सर।
से. Agreed?
यस सर।
So इसके बीच में whatever the shaded region now I'm going to draw in that part, I'll use black
देयर इज
color.
नो स्टार्टिंग वॉल्व ओपन।
There is no air starting wall open, right? And
ओके
if
ओके
your
सर।
engine has been stopped in this particular region, if your engine has been stopped in this particular region, you might have seen these pointers on your
फ्लाईव्हील।
flywheel, okay, where you're
यस सर।
checking kitna degree हुआ. So if your engine
यस सर।
has stopped in this yellow colored part region, then in those regions there is no air starting valve is opening. So how your engine is going to send air?
ओके ओके सर, समझ गया सर।
सर एक डाउट है सर।
Yes, बोलो.
सर जैसे 4 यूनिट है या फिर मोर देन 4 यूनिट है, तो उस केस में जो आपने बताया ओवरलैपिंग होगा, ठीक है? तो
Four
सपोज
or four, more than four, four and more than four, huh?
ये सर
हाँ.
तो उसमें चांसेस है कि ओवरलैप हो भी रहा है, ओवरलैप ना भी हो रहा है, उसमें दोनों चांसेस है। तो जो
Yes.
क्रैंकिंग, हाँ, जो क्रैंकिंग इनिशिएट जो करेगा, स्पीड जिस स्पीड से क्रैंकिंग इनिशिएट करेगा, तो ओवरलैपिंग के वक्त जो क्रैंकिंग स्पीड होगा, और जब ओवरलैपिंग नहीं हो रहा है तब जो क्रैंकिंग स्पीड होगा, तो दोनों में तो
यार
डिफरेंस
मैं
होगा, है ना
कंफ्यूज हो
सर?
गया क्या बोल मैं कंफ्यूज हो गया क्या बोलना चाह रहे हो आप? फिर से बोलो.
जैसे कि जो हमारा पॉइंटर है,
Yes.
तो इंजन जब स्टॉप हुआ तो ओवरलैपिंग के रीजन में हमारा पॉइंटर आ चुका है और तब स्टॉप हुआ है।
Okay, that means I'll draw it here. Okay.
ये
Suppose pointer has reached here, right?
यस सर, हाँ सर।
Okay.
तो
Okay.
इस केस में जो हमारा क्रैंकिंग का जो इनिशिएटिंग स्पीड होगा वो स्पीड। अब दूसरा केस
That
है
will
कि
be
जब हमारा
slightly higher, right?
अच्छा, तो
Your
ओवरलैपिंग के वक्त जो होगा वो क्रैंकिंग स्पीड हाई होगा, मैं यही पूछना चाह रहा था।
Yes, slightly it will be higher because two units will be getting here, right? Simultaneously.
ओके ओके सर।
सर अभी वो बाकी
हाँ,
ऊपर वाला पार्ट।
what you have to write?
नहीं नहीं सर, वो एक क्वेश्चन और भी होना डाउट में था ना सर,
क्या
स्टार्टिंग जो
क्या
आपने
था doubt?
समझाया था 78।
What
वो
was the
पहला
doubt?
वाला 78, ये सर
This one?
ये वाला पार्ट ये। हाँ, जो 80
Okay.
90 अचीव हो रहा है, फिर वो
Okay. Okay.
कैसे।
Understood. Understood. Now, what I was saying here is the question was understood.
नहीं
सर
क्वेश्चन मेरे को फिर से बता दीजिए।
Question is this, that if 20 bar 30 bar air you are injecting, okay, so the piston will move down, your crankshaft will start to rotate. Agreed?
यस
Yes sir.
Okay, but at the end of the for other unit the piston might be going up.
Yes sir.
Okay, इसमें नीचे आ रहा है, so some unit might be going up also, right?
Yes
And
sir.
at the end of the compression आपको pressure मिलता है 80 to 90 bar, right? So will this pressure will not oppose this piston coming up?
सर ये 80 to 90 बार, इसका मतलब क्या इधर भी स्टार्टिंग बॉल में हवा डाला क्या, मतलब इंजेक्ट किया?
नहीं नहीं नहीं, अभी नहीं डाला है. This air starting valve is not open right now. ठीक है, because piston is down ना. It is injecting
हाँ जी
11 degree after TDC. Agreed?
यस सर
Okay. So if I have to, you know, take this collectively, I will take average pressure. 80 बार डायरेक्ट तो नहीं लूंगा ना यहाँ पे. On this point, suppose my air was at 10 bar of pressure, for example. Okay, at this point 10 bar था, यहाँ पे 20 हुआ, यहाँ पे 30 हुआ, 40 50 and so on, and finally reaches to 80, right? But I have to take at this point of the piston, I have to take the average value of this.
Yes, sir.
Okay, average value will obviously come very less than this one, which I am getting at the TDC. I have taken
Yes,
that
sir.
यस सर
average value to around 10 to 12 bar. Okay, but here I don't have to take the average value, isn't it? It is directly acting on top of my piston.
यस सर यस सर
Agreed? Okay,
यस
so
सर
here my force will be greater because pressure is greater.
यस सर
Area is common for both. Agreed? Piston ka area is common. Same diameter pistons we are using. Okay, all the units, but the pressure difference is coming, right? So force acting on my number one unit will be higher. Agreed?
rather than two.
And that is why your engine will keep rotating. Okay.
सर यहाँ पे एक और डाउट है सर. ठीक है, ये आपने बताया कि यहाँ पर 30 बार है, यहाँ पे एवरेज प्रेशर 10 बार है, तो फिर भी हमारा 20 बार से ये मतलब कि वो कर रहा है, ज्यादा है. तो इस तरह से 6 सपोज 6 यूनिट है, तो सर इसमें 6 जो बाकी के 4 यूनिट है, तो वहां पे सर 40 बार हो जाएगा ना. सपोज एवरेज प्रेशर 10 बार है, तो 10 10
Baba,
10 40 बार हो जाएगा ना.
it doesn't mean कि यहाँ पे if air has injected now, other units will also some other unit will also inject now. It is
तो
not
सर
now
जब
only
अगर
one unit is.
सपोज
Wait.
सर,
I have told you ना overlapping is happening.
ओके, और जब अब ओवरलैपिंग ना हो रहा होगा तब.
तब भी you have the still the momentum ना from the overlapping part of this. See, this unit has given air. Now maybe number 5 unit after this has also given air.
यस
ओके.
सर
Okay. After this number 5 unit might have given air. Okay. Suppose overlapping is not even there. After 1 unit, number 5 unit start giving air. So again the momentum has been built up na. It will
यस सर.
overcome this average pressure part, force F2. Agreed?
सर एवरेज प्रेशर तो ज्यादा ही होगा।
नहीं,
नहीं
average
नहीं, वो
pressure
कम
में
होगा ना,
ज्यादा कैसे होगा?
कम होगा ना, वो 10 बार होगा, अप्रॉक्स 10
It will be
15 बार.
it will be
आपने
obviously less ना average.
नहीं सर,
मतलब सर
कैलकुलेट
क्या
करके देखा मैं अभी, ज्यादा ही आ रहा है।
कैसे ज्यादा आएगा?
10 प्लस 20 प्लस 30
If
प्लस 80
if
तक ही
if
है।
I start one engine at 100 RPM and if I start one engine at 5 RPM and I increase gradually, so average will be coming next more in slow start.
नहीं उस समय नहीं आएगा।
That is
मैं
what
एक
I am
यूनिट का।
explaining. That
ओके
is what
ओके।
I am explaining ना. Okay, average pressure will be less. 80 से तो ऊपर जाएगा नहीं ना. That is the
नो।
maximum pressure that it can
यस
develop.
यस सर।
Sir, is it called MEP?
What?
MEP. This one is MEP, right?
नहीं
Mean
नहीं
effect.
नहीं.
This can
मोटर
be MEP also. This can be motor also. Okay. This can be common both. Auxiliary engine normally comes.
No, sir, that is not
Sir,
mean effective
he's
pressure.
asking whether it is the mean
Normally it
effective
is
pressure.
4B. Normally it is
Sir,
4B actually. Motor part.
नहीं
Discharge
नहीं,
pressure है
तो
sir.
मीन इफेक्टिव
हाँ,
प्रेशर पूछ रहा है वो.
That is
Mean
not.
effective pressure.
That is that is not what we are discussing right now. Mean effective
Yes.
pressure will come after firing has happened, right? So right now
ये
we are
खाली
not
कंप्रेशन
firing.
प्रेशर है ना सर?
This is only compression pressure.
हाँ सर।
अभी तक हमने फ्यूल नहीं दिया ना, right? During
Hmm.
initial
हाँ
cranking of your engine, I'm not giving fuel, isn't it?
हाँ सर, पहले तो हवा ही था।
Okay. After cranking only the fuel is given. So you have to
Yes, sir.
have achieve a minimum, cranking RPM. Okay. You have to achieve a minimum cranking RPM in order to have this compression pressure. And that is around 20 to 25 RPM of your engine in main engine. Until and unless your engine starts to turn only on air at this RPM. इसको बोलते हैं minimum cranking RPM. Okay.
सर ये रेंज इररिस्पेक्टिव ऑफ साइज एंड होगा।
No, slightly it can up and down. Okay. Minimum cranking RPM. Okay. Slightly it can be up and down also. Okay. But I'm giving an average idea. Okay. Just day before yesterday, one of my friend called me. He's a second engineer now. Okay. First contract. And his engine was not starting. Okay. And he's very tense and all. He called me and all. And he was asking me this question like, engine is not starting. And he was tensed about it. Okay. And he was not getting what is the problem. So we discussed a lot, and afterwards he told me that the RPM, maximum RPM my engine is going is around 10 RPM when I'm starting the engine. And I said to him, you will never develop this, compression temperature that we are developing now on top. Agreed?
Yes, sir.
520 to 550 degrees Celsius, what I discussed before. You will never develop until unless minimum cranking RPM has been achieved. So if your RPM is less than that and you give fuel, your engine will not start. Okay. So you have to have this much RPM in order to produce that much compression temperature.
ऑटो इग्निशन
So
टेम्परेचर रहती है।
auto ignition temperature, right? So for that part, I should not jump here, but still I tell you. What was the problem there is two things coming in this diagram, what I'm going to explain. Okay. At the end, I'm going to explain this maneuvering diagram to you. But for that, I have to clear your base and all. Okay. What was happening during the initial start of your engine? Okay. You will understand this diagram once I will complete the topic. Okay. So what happens is this is my starting air manifold. Okay. This is the starting air manifold. Okay. From here, the air is going, and this is my starting air valve. Okay. Starting air valve. So what was happening? His engine was only able to generate 11 RPM. It was not going more than that. He tried locally. He tried, from bridge, from engine room, everything. They did not. It did not go more than 10 RPM. Why it was not going? You see from here, I have two walls over here. This is one. This is two. Right? I have two walls. This is the 30 air bar pressure which is coming. Okay. Also, this you see यहाँ पे tapping here. This is a tapping here. Agreed? This is also 30 bar. But the diameter of the pipe is comparatively very less. This is going for the slow turning of the engine. Okay. So during initial kick, both of the valves opens and give combined 30 bar air here both the times and deliver to your engine to start it. Okay. But now what was happening on his ship, what I gave him the advice was the solenoid valve. There will be two solenoid valve. Okay. One for exactly this and one for exactly this one. So this solenoid valve was not working and only air was going from the slow turning valve. And that is why his engine was not able to pick up the RPM. Okay. So you will be able to understand this. Before that, I'll come to a simpler diagram. This is the same diagram I'm going to explain you. Okay. That I've drawn over here. This one. So can I start with this?
Yes, sir.
Okay. So as soon as you have in your telegraph, suppose it is in stop position, your telegraph. What do you have next one? Next point.
Dead slow.
You have first
Dead slow add.
start.
अच्छा.
After start comes that slow ahead. Okay, and similarly that slow head के बाद क्या आएगा? Slow head, full
Slow head.
head, and nautical full and all those things. ठीक है, on top. Similarly on bottom, what will be coming? Start, and then that slowest turn, and all those things. ठीक
Dead
है,
F
down.
and start.
So when you bring your pointer, suppose normally when the engine is stop, your telegraph is in stop position. Agreed? Then what you do? You put it on start. As soon as you start, what is happening? As soon as you put the telegraph on start, what is happening? The control air comes from here, 7 bar. Okay. As soon as you put it on start, this uh, master valve vent will be closed and it will allow the air to go further. This 7 bar air. This 7 bar air is going to check all the interlocks. I will explain you later on what all interlocks do we have. Okay. It is going to cross check all the interlocks and it will verify if any of the interlock is active. If any of the interlock is active, this air will not go further. Okay. Suppose low by low pressure interlock is active. Okay. So it will not give any pressure further. But if all interlocks are fine, completely fine, nothing is, no hindrance is there, then this air pressure will go further. Right now, leave this part line. Take a slow turning wala. I will
So
explain
what
later.
is this vent in, you said in master valve?
Normally, once you put it on stop, na, so it will vent the line air. This line air, na,
Okay.
this line air will be vented out from this master valve. Okay.
Okay, sir.
I'll come to that. Okay. So now this air will go here and it will hit on the auto starting valve. Until this 7 bar air comes and opens your auto starting valve, your 30 bar air will not go to your starting air manifold. Okay. It will only go to starting air manifold only after the 7 bar air is opening up your auto starting valve. Okay. Now this is the manual valve. आप खोलते हो during each maneuvering you are opening na air bottle valve.
Yes, sir.
Yeah. So this is that manual valve. You open it, but until this air comes, the starting air will not go forward. Okay. Now suppose the air has come, the 7 bar air has come, and now air is going further through this non-return valve into my starting air manifold, and this starting air manifold will be filled by complete by 30 bar air.
Yes, sir.
Yes, sir.
Agreed? Now this 30 bar air will be going to your starting air valve, air starting valve, which is mounted on top of your cylinder head.
Yes.
So this air itself cannot open the valve. Okay. This air can itself not open the valve until and unless my pilot air is also coming. Okay. Where is the pilot air?
ऊपर से जा रहे थे.
This is the pilot air. Agreed?
हाँ. Yes, sir.
Okay. Until this air also comes to this particular, what do you say, air starting valve, this air starting valve will not start injecting. So what happens? You see, this is a tapping given over here and the pilot valve, and the air is coming to my distributor. I told you this is my distributor. Okay. This complete part is my distributor. Later on, I will show you actual diagram of distributor also. Okay. But for now, just for understanding purpose, we will continue with this diagram. So this is my distributor. Right now, in this position, my piston, I have two pistons here, up and down, right? Upper and bottom. So bottom piston is blocking the channel of my pilot air. Agreed?
Yes, sir.
Okay. It is blocking the channel of the pilot air. Pilot air cannot enter to my distributor. So until and unless this air will go and push my piston down, till that time this air cannot move further. So once the air pressure comes, it will push my piston down and the upper piston will close this vent. Okay. When it comes down to close the vent and my 30 bar air can now go.
सर
Agreed?
ऊपर से भी 30 बार ही है ना?
नहीं, ऊपर से 7 बार है ना.
Which one ऊपर से?
ये
वो स्प्रिंग
जो स्प्रिंग के
एयर
नीचे आ रहा है. हाँ.
डिस्ट्रीब्यूटर 7
This
ये
7 bar,
कंट्रोलर है ना सर? हाँ
this is
सर.
7 bar
7 बार.
and this
और
is
सर ये
30.
जो स्टार्टिंग है मैनिफोल्ड से जो आ रही है. ओके.
This is 30 bar. ठीक है. Now you can argue here like this 30 bar will not allow this wall to open, but because of the area difference, okay? That's why I'm telling you, I will show you the actual diagram. The area is different on which the 30 bar is acting and on which the 7 bar is acting, okay? 7 bar is acting on a larger area, so force will be more. Is it okay?
Yes, sir.
Okay.
But this 7 bar is just to close the vent so that
It is
30 bar.
it is to bring this distributor cam down onto my negative cam, air distributor cam. So when it will come down here, then only it will push, pistons will come down. Agreed? Now this is
Yes,
the
sir.
for number 2 unit, number 3 unit, number 4 unit
Yes,
distributors.
sir.
These distributors cannot go down. Na? Only which unit distributor can go down right now in this
One.
diagram?
Only one.
Number 1 unit.
One.
Yes, sir.
Okay. This is number 1 unit, suppose. So only this distributor can come down. Agreed? Other distributor will stay
Yes,
in
sir.
the position itself. Isn't it?
Yes, sir.
Yes, sir.
Right? So air will be going, this 7 bar air will be going to all the units. Okay. All the units it will be going. But only that particular unit whose roller is on the negative part of the cam. This is the negative cam. Huh? I will explain later on about negative cam also. This is the negative cam. Only this roller can come down when the 7 bar pressure is acting on top. Agreed?
Yes,
Yes,
sir.
sir.
And if this pistons comes down, it will open the channel for my air to go further, pilot air to go further. Also, it
Yes,
will be
sir.
blocking my vent valve here,
Then,
right?
yes, sir.
So air will be going and only this particular unit will be getting air. Is it understood?
Sir,
Yes,
one more
sir.
time.
Ji, sir.
I'll go one more time.
Sir, the distributor cam, what is there? Does it rotate or
Yes, it is rotating with your camshaft.
okay, along with the cam? Okay.
Yeah, it is rotating along with your camshaft.
This
This
roller, no, sir.
auto starting valve, what is it, sir?
I'll start one more time. Okay, complete.
और सर ये ऊपर जो पायलट लाइन में जो पायलट वाल्व लिखा है ना ग्रीन कलर में
Yes, yes.
सर वो व्हाट इज दैट सर
Suppose I
मतलब
have to do
पायलट
some
और
I have to do maintenance on the distributor. So I will close that wall at that time. Okay,
ओके अदरवाइज इट इज ऑलवेज ओपन
always open. Okay, during normal time it is always open. So what happens as soon as I put my telegraph from stop to start? Okay, this air will go control air. Okay, it will pass through your vent will be closed of your master valve. It will pass through all the interlocks. I will discuss later on what all the interlocks are there. Like a turning gear interlock is also there. If turning gear engaged, your engine will not start. Agreed?
Yes, sir.
Manpreet Singh. What is it? Okay. I'll come to this. Okay, don't worry. So, what color should I use? I'll use black, but it will be thicker maybe. So, this air is going over here. Okay, air is going over here. This air is also going over here. This both are 7 bar. Agreed? Bolo.
yes sir
Yes, sir.
This air will open my auto starting valve. This valve is already opened by you. So my 30 bar air will flow through this non-return valve into my starting air manifold. From starting air manifold, it is going to my pilot valve, distributor, and also it is going to my air starting valve. So air starting valve, I have told you there are two parts, isn't it? Diagram mein? Where is it? This one, right? This 30 bar air, and this is the pilot air. Agreed?
Yes, sir.
Okay, so 130 bar air, that is your main air, that is available for all the units, right? यहाँ से एक और tapping रहेगी वो that is going to second unit air starting valve, right? So it will be going for all the units. There is no restrictions to it. Agreed?
Yes, sir.
Only
Yes,
the
sir.
pilot air will be the one which will be able to open it, right? So all the units are
Yes, sir.
getting this air. All the units are getting this air, but this 7 bar air, when it will come, it will try to push my piston downward. Do you agree? Against the spring pressure.
yes
Against the spring pressure, it will try to push the distance of my air distributor down. Okay, but only that particular unit will come down whose roller is on the negative part of the cam.
Yes, sir.
Others will stay in its position itself. वो तो जा नहीं सकता ना, तोड़ के तो नहीं जाएगा cam को.
Yes.
Agreed. So only number 1 unit can come down, right? At this point. So this piston, when the roller will come down, when the 7 bar pressure is acting, the top piston will block the vent. Agreed? And the bottom piston will move little bit downward, opening up the channel for my 30 bar air to come.
Yes, sir.
And only this particular unit will be getting air from the pilot air, and only number 1 unit will be injecting air into my cylinder. Is it clear?
Yes, sir.
Any doubts in this?
सर ओवरलैपिंग 2 यूनिट से भी ज्यादा हो सकती है ना, 3 में भी हो सकती है, 4 में भी हो सकती है, मतलब डिपेंडिंग अपॉन द नंबर ऑफ यूनिट्स.
डिपेंडिंग अपॉन नंबर ऑफ यूनिट्स, बट मोस्टली 2 में ही रह पाती है. ठीक है, उससे ज्यादा इतने बड़े इंजन तो अभी तक बनाए नहीं. ठीक है
सर एमई में आपने बोला सोलेनॉइड वाज कंट्रोलिंग इंस्टेड ऑफ कैम, तो
ME
इसको कैसे
में what is in ME is there. This complete part is not there. Okay, you have a solenoid valve here present. Okay, this is coming from the pilot air. Okay, whichever solenoid valve will open, that particular unit will inject. Agreed?
Okay, sir. Instead of cam, the angle encoder will give the signal, the position
in
of
ME
the.
engines we don't have in camshaft and all those things, right?
Yes,
So
yes.
there is just one solenoid valve, very easy. Okay, it is a computer program which solenoid valve will open at what time. That is already being set according to your diagrams, all timing diagrams and all. Okay, so the solenoid valve will open and it will give your pilot air. That's it, finish. Rest all system will be common, but this system, will not be there. Interlocks will be there, your auto starting valve will be there, non-return valve will be there, starting air manifold will be there, but this distributor will not be there. This part will not be there.
Okay, sir.
Means this auto starting valve, all the function will be there. Only this distributor part will be neglected, right, sir?
Yes. Okay, because there's no cam itself, so how the camshaft, this negative cam, how it will rotate.
So this solenoid will allow the 30 bar to act on the top, and from the one side it
solenoid
is coming
valve
the
will open the pilot air for the valve. Okay, यहाँ पे एक solenoid valve लगे रहेंगे for all the units. Whichever solenoid valve will open that particular unit, this is always active for all the units, but this
Yes, sir.
solenoid valve will be active as per your computer program, and that particular unit will be injecting air. Clear?
Yes, sir.
Okay, sir.
सर एक कैम के बारे में प्लीज फिर से बता दीजिए.
Yeah, will come, don't worry. Okay.
Okay.
Tomorrow also mostly we will be discussing this diagram only. Okay, this diagram will give you a lot of answers actually. Okay, a lot of questions are being asked just according to this diagram, not just in your oral but also in your written. All right, so now we'll discuss one by one. So what all safeties do I have here?
Burst disc, flamer.
Okay, suppose after start signal you have given, na? Once you guys, you can hear me, right?
Yes, sir.
Okay. Yes, sir. So now I have told you from stop to start when you did your air, how the air is going to your engine, right? Now what I say cranking RPM. Once the cranking RPM has been achieved, okay, you will shift the telegraph from start to dead slow head. And as soon as dead slow head is given, as soon as the dead slow head will be given, okay, this control air will be cut off, which is coming over here. If this is cut off, what will happen to my
air starting valve? It will be cut off.
It will be shut. Okay, if this air is cut, that is good. If this air is not present over here, what my springs are going to do? It is going to pull back my plunger up. Agreed? Distributor plungers will be pulled upward by the spring pressure.
Yes, sir.
Because once I have started my engine, do I need to operate my air starting valve?
No, sir.
No. So what it will do, it will pull the plungers up. Now engine is rotating, so cam is rotating, but cams are not going to touch my plungers, right?
Yes, sir.
Because of this negative cam. Suppose I have given a normal cam, what you're seeing onto your, what do you say, four-stroke engines and all, okay, or other fuel cams and all, okay, exhaust valve cams and all. So in this part, it will always touch. Even I don't require a air starting valve after starting my engine. But if I have this type of cam, will it always touch my, always move my plungers of my air distributor up and down?
Yes, sir.
Okay, that is one of the reason I am giving a negative cam, so that if my engine is started on fuel, I will not be requiring the operation of my air distributor. Agreed?
Yes, sir.
The spring will pull my plungers up, and now my cam, even if the cam is rotating, it is not giving any air to my pilot air to my air starting valve. Agreed?
Yes, sir.
If the plungers are pulled upward, whatever air was remaining in this line will be going out from the vent. Agreed or not?
Sir.
If my plunger is
Yes,
pulled
sir.
upward, my vent will open and the passage for the pilot air will again be blocked.
Yes, sir.
Okay. And vent will release all the pressure inside this line. Whatever pressure was there inside this line, it will release it. Agreed?
Agreed, sir.
Okay. In
सर एक
case,
डाउट है सर
हाँ बोलो,
सर अभी इसमें जो
थोड़ा
डिस्ट्रीब्यूटर
जोर से
कैम
बोलोगे.
है कैम सर डिस्ट्रीब्यूटर कैम है वहां से सिर्फ एक ही यूनिट पे एयर जा रहा है स्टार्टिंग टाइम पे तो सर
Correct.
ओवरलैप के टाइम में तो दो दो यूनिट पे जाना चाहिए तो
Yes,
वो
दो
उसके
पे
लिए कैम
जाएगा.
कैसे हो अच्छा, मतलब उसी में आ जाएगा
I have drawn only 4 ना here. ठीक है.
ओके
I have, just for explanation purpose, I have drawn it like this. Okay. I'll show you.
ओके सर
Oh, sir, one more doubt is I mean,
हाँ बोलो.
sir, if 7 bar pressure can open auto starting air valve, then why 30 bar from main air water cannot open it?
Actuating mechanism different है ना.
Okay.
You see the
तो
actuating
कोई
कैसे है यहाँ पे. Now, if you want
सर
in
ये
detail, this one, I will explain you later. Okay.
yes sir, yes sir.
I will show you how it is applied. This is the one that I told my friend to check the solenoid valve. You see here solenoid valve है यहाँ पे. This is what was defective in a ship. Okay. So air was only going from this slow turning valve, which I'll come to some time. Okay. And it was getting less amount of air. Okay. I'll come to this later on. I forgot what I was showing you. Okay. So you see here, this is my cam. Okay. This is the negative cam. Okay. Negative ahead cam and one negative astern cam is also there. So right now, when my engine is going to, start, you see this can come down. This particular piston can come down, plunger or the roller.
यस यस सर
Where
Yes,
my
sir.
cursor is. Can you see my cursor?
यस
This
सर
can come down. But what about the others? Can these come out? Come down?
No, sir.
Okay. Only this one can come down. Right now, there is no overlap. Okay. Now, if you turn, you see only this number 6 is coming down, right? But what about right now? This one also came down.
यस सर
Okay. So this is your overlap. You see, this is also open. This is also open. This is also open. This is also open. You understand?
यस सर
Yeah.
अंदर अंदर वाला एस्टर्न है बाहर वाला हेड है ना सर
अंदर वाला ahead है. This is ahead. And the outer one, you can see the outer one में भी आपको दिख रहा है, right? This is astern one.
हाँ सर
When you will give
वो
astern kick, wait. When you give astern kick, this plunges will be pulled backward. Okay. That's why I told you this is diagram for explanation purpose, and also you can draw it. Okay. But actual diagram of this particular part I will show you later. Okay. In astern also I will show you how the things is happening. So पहले head वाला समझ लेते हैं. ठीक है.
So only by looking, if the main engine is not moving, How will we understand which cam is for ahead and which is for astern?
It is written.
अच्छा ओके
See,
हाँ हाँ
AH.
फोर
Can you see AH
हाँ
written
सर
over here? Yeah.
हाँ
So
सर हाँ सर
this is ahead. Okay. And in this, it is rusted right now, but it is written as turn for that. Okay. Is it
हम्म
clear?
हाँ सर
Okay.
ओके
So, what was safety? Safety is good. Huh? So first of all, you understood as soon as I gave start signal, what happened. Okay. After I have achieved cranking RPM, I have given dead slow head. You understood what has happened after I have given dead slow head. Agreed? Bolo. As soon as I have given dead slow head, the air has cut off this air. Agreed?
तो उसको पता कैसे चलेगा सर अगर मतलब दैट दैट स्लो हेड हैज रीच
This no. As soon as you lift your, there will be a lot of electronics things down below in your telegraph and all. Okay. Also
ओके
switches and all. So that will give a signal. You can see over here. If this is your telegraph. Okay. This is a different type. Okay. So you see in this I have first of all ahead and astern acknowledge करने के लिए. Sometimes you can have both as combined as one only. Which पे आपने you might have seen. Okay, that is there for timer based they will do. So as soon as you put on dead slow head, a timer will activate. Sorry, as soon as you put from stop to start, timer will activate and it will give air for specific period of time. And after that, it will give fuel and your air will cut off. But in this type, I have separate. This is to acknowledge the direction and this is to start the engine. Agreed?
यस सर
अब आप देखो यहाँ पे स्टॉप के बाद क्या आता है
स्टार्ट
स्टार्ट. So once you put this lever on start and your telegraph is in dead slow ahead or something, okay, once you give on start, only air will be injected. Okay, only the air will be injected. And as soon as you have achieved the cranking RPM, you will put this lever onto your 1 or 2 or whatever you will want to put. That will be according to RPM, right? You can see on top it is written over here. Okay, for dead slow, how much RPM to maintain, and for slow ahead, how much RPM to maintain,
ये
right?
फ्यूल लेवर है ना सर दिस
This is
वन
fuel. This is air and fuel lever
यस
both, huh? Both.
ओके ओके
This is only to acknowledge the bridge call. Okay.
ओके
Sometimes these both are combined together. एक combined दिया रहता है, एक ही दिया रहेगा दोनों में से, which is this one. How it will operating? It is operating as soon as suppose उसमें क्या रहेगा? There will be no start. Exactly from stop, it will be dead slow head. So as soon as you put dead slow head, timer will activate and first it will give this air and your air will be injected. After cranking RPM has been achieved, okay, it will not be sensing the RPM, but it will be sensing the timer, how much time it is taking to achieve the cranking RPM. According to timer, the setting will be done. According to timer, what will happen? This air will be cut off then, and then the fuel will be given. Puncture valve will. You have taken my fuel pump classes, right?
यस सर यस सर
Puncture valve, safety air will be cut off from top. Okay, if the safety air is cut off, then it will start to give fuel as soon as the
यस
यस
safety
सर.
air is cut off, right?
यस
पंचर
सर
वालों पर उड़
Okay.
जाएगा.
So I think fuel pump is clear to everyone, I guess, right? Is there any problem with
हाँ
fuel
देखो.
pump?
नो सर नो
नहीं सर.
Why we don't run an engine in 60-65 RPM?
Vibration.
क्या मतलब? Critical RPM? Is it? Yeah. Are you talking about critical RPM and all for your engine?
Yes. Yes, sir. Yes, sir.
That is vibration part of it. You see here in this, what is written over here? Bar speed range. Somebody can read out? Normal condition, no bar
नॉर्मल
speed range.
कंडीशन
Okay. Because if you have attended my vibration part, hold on, my laptop is dying. I'll charge it. Yes, so I have explained this in my vibration class, isn't it? Bar speed range. Who has attended this session? Can you answer this now? I don't have a bar speed range in my this ship. Okay, maximum RPM of this ship was around 100 RPM. What could be the reason I don't have a bar speed range or my critical RPM range here? चलो guys, बोलो.
क्रिटिकल
What could be
आरपीएम
the
वाला
reason?
जो आपने बोला वही 20-25 ना, वही क्रिटिकल आरपीएम.
No, that is minimum cranking RPM. Critical RPM is the
ओके.
one in which the natural frequency and the induced frequency are going to match up, right? It is also
मैच.
known
हाँ
as bar.
हाँ सर.
It all depends upon
बारिश से
the vibration characteristics of your engine, right? Of your ship and your engine. What did I explain you about TOW 1 and TOW 2? I am going to little bit divert from this topic now. Okay, vibrations. There was TOW 1 and TOW 2 value. And the curve was like this. If your vibration characteristic curve is going like this, then first I have to give what? Torsional vibration damper. If I give torsional vibration damper, the curve will go downward. O1 is the value that the, come on guys, bolo, vibration पढ़ा दिया है मैंने. Speak up, Ananya. You asked me about question about this thing, right? Vibration. Was it you or somebody else? किसी ने vibrations के topic के बारे में
No,
कुछ
sir.
पूछा था? Somebody asked me few days back vibration topic. Some question was asked to me. So Aaron, you have attended the session, isn't it?
नहीं सर, वाइब्रेशन के लिए नहीं था सर.
सर मैंने एक क्वेश्चन पूछा था आपसे, वो एक्सल वाइब्रेशन डैम्पर और थ्रस्ट ब्लॉक में वो डिफरेंस है.
नहीं, उससे पहले भी किसी ने पूछा था. What? Also, okay, I'll come later. Okay, let us not deviate from the topic. So what you're asking here is, might be your ship critical RPM range was 60 to 65 RPM on your ship. Okay, and in that RPM, your governors are designed to give more fuel to cross that RPM faster because vibrations will be very excessive. Okay, at this RPM for your engine, not for all ships. I'm telling you. Okay, in my ship there was no critical RPM. You can see over here, normal condition, no bar speed range. Okay. So until and unless I have cut off one unit and all, then the bar speed range will come into action. But in my ship, it was not there because of the vibration characteristics of my ship and my engine. Okay. It will all depend upon, you will understand it if you attend vibration class. Okay. About this thing. I don't want to deviate right now. Okay. So can I move further with this topic itself? Bolo.
यस सर.
Yes, sir.
यस सर.
All right. So now in this, I have told you once I put from stop to start what has happened. Okay. Now if I from start to stop, if I put, what is going to happen?
स्टार्टिंग वॉल सर एयर सप्लाई में
Nothing,
बताओ
right?
बताइए.
Nothing will
इधर
happen,
कुछ
isn't it?
स्टार्टिंग वाल में नहीं. हाँ सर, नथिंग विल हैपन. पंचर वाल थ्रू एयर जाएगा सर.
Only puncture wall air will go to the fuel pump.
यस.
Agreed?
यस सर.
Nothing else. That we will discuss when I will discuss you this diagram. No? Then I will tell you this air will go here as soon as you put the stop signal. Okay. There are few, those who are asking कैसे इसको पता चल रहा है. You can see there are solenoid valves. Start, stop, astern, है.
हाँ 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 सर.
Okay. So these solenoid valves will be there on the bottom of your telegraphs. Okay. As soon as you put on start, this solenoid valve will be active. As soon as you put in ahead, that means that slow ahead, this solenoid will get activated. As soon as you put stop signal, this solenoid valve will be getting activated. It will go and it will operate your puncture valve. Is it clear?
Yes, sir.
And all of these are controlled by your control air and safety air. Okay. ये जो सारे सिग्नल जा रहे हैं, this is air signal only. This is air going into that part. So everyone knows about this solenoid valves, no? What are these solenoid valves? Or that these are not called solenoid valves, these are called as actually directional control valve. Okay, 2x2, 2x3 बोलते हो ना आप लोग? These are directional control valves. So these are fitted
Yes,
on bottom
sir.
side of your what do you say, this telegraph. ठीक है, telegraph के नीचे रहते हैं. It's continuous. So beneath your telegraph, okay, these beneath your telegraph and beneath this handle, this directional control valve will be situated. Okay, and as soon as you're giving start signal, you're actuating the start directional control valve. Is it clear? Before I'll explain you this diagram, I will explain you about directional control valve also, so you will understand much better. Okay, there are so many directional control valve you can see over here. Okay.
सर स्टार्ट देने के बाद ही वो एयर स्टार्टिंग बॉल एक्ट करेगा ना मैकेनिज्म?
Yes, only at starts. Okay, can I move further?
Yes, sir.
Bolo, can I move further?
Yes, sir.
So in this diagram, if you see, tell me what all safeties are there in this diagram.
Bursting
बस्टिंग
distance.
दिस
They will
flame
ask you
arrestor.
what all safeties are there in your what you say starting mechanism. Okay.
Interlocks.
Interlocks.
Interlock.
Interlocks.
Okay. So you have
Vent.
interlocks,
Sir, vent.
then master valve also you can say. Okay. Then
Slow
you
turning
have
valve.
auto starting valve is also kind of a
Valve.
safety. As soon as you're cranking RPM that slow
Seven
head
bar.
it is given, it will shut off. Agreed?
Yes.
Okay. Non-return valve is a
Non-return
safety.
valve.
If crankcase explosion, crankcase बोल रहा हूँ, starting air explosion होता है, so it will not allow air to go back to your main air bottle. Do you agree?
Yes, sir.
Okay, main air bottle में चला गया एक बार तो हो गया ना काम. There will be a
हाँ सर.
much bigger explosion. Okay, that is why this non-return valve is provided over here. Then you have a drain valve on your starting air manifold.
Yes sir.
Okay, once your engine has been started, you should drain the line because there will be some accumulation of water, or when the air will condense, there will be accumulation of water, and also from main air bottle some
Moisture.
oil content might come. Oil content आता है ना from your
Oil carryover.
compressors. Oil carryover comes to your main air bottle. From main air bottle can go to your starting air manifold. Agreed?
Yes sir.
So this is a drain valve. People are forgetting about this drain valve. Very important to mention in safety. Starting air manifold drain valve. Okay. Then you have this TP. What is this TP?
Thermal patch.
Thermal patch. Okay. This is a color coded patch. Okay. This is a color coded patch. It will show if the temperature of your starting air manifold is increasing. Okay. How the temperature of starting air manifold can increase? Suppose if my air starting valve is leaking, okay, you see over here in this
Exhaust
part,
gases आ जाएंगे.
exhaust gas might come back after
In the
starting
starting.
because there will be no pressure. So from here, my air can come in, right? Exhaust gases
Yes
go
sir.
back to my starting air manifold. That is how a
Yes sir.
starting air manifold explosion happens actually. Agreed?
Yes sir.
For that purpose, a thermal patch is also provided. Okay. First of all, to make you understand that my starting air manifold temperature is increasing. Then I have bursting disc. Okay. I have bursting disc. I have flame arrestor. This is also safety.
Yes sir.
Okay. So this is understood what all safeties are there.
No, flame trap and flame arrestor is same, no?
फ्लेम ट्रैप फ्लेम अरेस्टर सेम थिंग, यस। अरेस्टर का दूसरा नाम ट्रैप ही है ना। ओके, आई विल कम टू वन बाय वन ऑन ऑल दीज पॉइंट्स। इंटरलॉक्स पे भी आऊंगा मैं, ठीक है। आई कम टू फ्लेम अरेस्टर आल्सो, बर्स्टिंग डिस्क, ठीक है। Now, in case of Sulzer engines, we don't have a bursting disc, but in place of bursting disc, they have given a relief valve. Okay, on the manifold itself. Is it clear?
Yes, sir.
Okay. All right. Now, these are the safeties part. Huh? They ask this question: what all safeties are present? So you have to, if you remember this diagram, if you practice this diagram 2-3 times, you will be able to tell this. One more safety is there, that is slow turning valve. This solenoid valve is for slow turning valve. Okay. Now, what is the slow turning valve? So
सर एक चीज,
suppose, yes, follow.
सॉरी टू डिस्टर्ब सर, जब
No
अपना
problem.
ये कंट्रोल एयर आएगा मास्टर वॉल्व से सर, मतलब ये नीचे से होते हुए लाइन इंटरलॉक्स को क्रॉस करते हुए, तो
Yes.
ये 7 बार एयर अपना स्लो टर्निंग से भी जाएगा और ऑटो स्टार्टिंग
वो
वॉल्व भी से जाएगा
वो
ना सर?
वही 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 समझा रहा हूँ ना अभी। Let me start. हाँ?
May I?
ओके सर।
Okay. So now you all are putting standby to your engines. Standby press करते हो?
हाँ जी सर।
Okay. Here the figures are given over here, not very clear. But here my buttons are there for putting, not here, here. Right now it is on standby. Right. This is finished with engine. Right. And this is for your once at sea. Okay. So these 3 buttons are there. Agree? So right now on standby, my engine is on standby and it is running at that slow head of some RPM right now. Okay. From the bridge. So what happens as soon as you press standby, a timer will activate. Okay. And if now before you have done your engine preparation, your 2 hour notice has been given, what all things you are doing?
Turning the main engine.
Notice दिया आपको, what all things you are doing?
सर
तो सिलेंडर
टर्निंग
लुब्रिकेशन स्टार्ट करेगा, उसके बाद टर्निंग करेगा।
Turning gear से you are turning your engine. Why you are turning your engine?
टू चेक द फ्रीनेस ऑफ वो अपना क्रैंकशाफ्ट सर।
Lubrications.
Lubrication के लिए you can
Lubrication
just
and
press
to
lubrication
clear
के
off.
लिए you can just press pre-lube button on your alpha lubricator. I've told you before, alpha lubricator session. You can press
हाँ सर,
pre-lube.
after starting the pre-lubrication, we start turning the engine. The
Correct.
turning is done to take off all the any matter from the uh, piston crown, top of the piston.
But what is the main purpose of it? It is to
Sir, may I?
understand if my piston is stuck somewhere. If
चेक
my
द
piston
फ्रीनेस ना
is,
सर।
suppose my local welding has happened, micro seizure has happened between piston ring and my liner. Okay.
Yes, sir.
Or if there is any damage happened to my engine, okay, and if I directly give 30 bar air to it, what is going to do? It is going to break things apart. If my piston is stuck in my liner,
यस सर।
so
Yes, sir.
I start preparing my engine by turning my engine. Okay, lube oil you will give, pre-lube you will press, and you'll go down. You'll start turning the engine to see that my piston is free movement is there inside my piston in the liner. Okay. Now
Yes, sir.
during this turning time, what should you observe? कैसे पता चलेगा आपको if there is any restriction coming or not? Suppose
Turning gear
liner
का
के
एम्पियर
ऊपर,
से
yes, ampere you have to see. So if this is your liner and this is your piston, suppose liner has cracked and water has come into it, how will you come to know? Okay, this is cylinder head piston. Now if I give directly 30 bar air, what is going to happen here over here? Hydraulic lock. Follow. If water has come on top of my piston, and if I give directly 30 bar air on top of it, the water is going to break components or not, or it
Yes,
is
sir.
going to heavily damage your piston and liners and all. Agreed? So what I do is
Right,
I
right.
will connect my flywheel to my turning gear and I will turn the engine. So engine will go very slowly up. I will always keep an eye on the ampere of the motor. Suppose it is right now 10 amps, showing me 10 amps while it is turning gear motor ka amps. Okay. And suddenly it jumps to 20. What does it mean?
Obstruction is there, sir.
Obstruction is there of the
There is
piston.
some obstruction to the movement. That is the point I should stop and I should inform whoever the duty engineer is. Okay. That, sir, some problem is there. The ampere is rising. That means there is some problem with the engine. Don't turn it. Don't start it. Okay. That's why 2 hour notice has been given to you to make you understand that if everything is okay or not. If not, you have little bit time to correct it down or not. Okay. If obviously if it is water coming into my piston from liner or to my cylinder head, ठीक है कहीं से भी आ रहा है अगर, so I can ask for more port stay and I can go for the repairs and all. Agreed. But if suppose suddenly I give 30 bar air, then gone. Everything is damaged. Agreed.
Sir,
That is why
in case
as bolo.
sir, in case of high amperage, how it will come to know that which unit is in like
In
किस
case
unit में
of
problem है?
पॉइंटर रहता है फ्लाईव्हील पे,
In
in
case
case
of
of
high
what?
फ्लाईव्हील का
amperage,
डिग्री.
in case of high amperage turning
Yes.
gear, how it will come to know that which unit is with problem?
वो तो आपको चेक करना पड़ेगा ना जाके फिर. Then you have to do the inspection part of your engine, right?
तो सारे units को
फ्लाईव्हील पे भी देख सकते हैं ना सर?
Yeah, flywheel also you can see where actually it is happening. Pointer देखो उसके correspondingly which unit it is there, but it doesn't mean that unit only will be there. It could be some other unit also. Pistons are
अच्छा.
not up only for one unit. Agreed?
Yes,
okay.
yes,
So
yes.
for generators, we are not doing right
What?
for auxiliary engines.
Auxiliary engine में turn करते हो ना आप start करने से पहले. You're not turning. Then that's a wrong practice.
सर खाली ब्लो थ्रू करते थे, टर्न.
No, it should be turned. It should be turned. Okay, before you are not doing the correct process. That means. Okay, your third engine is not following the correct process. It should be turned first of all. Either for the Tommy bar or a turning gear motor will be given. Okay, some engines might have Tommy bar, some engines might have turning gear given to it. You have to turn the engine first of all. Okay, you are skipping in auxiliary engine. Okay, but that is not a good practice. You have to turn the engine. Is it clear?
Yes, sir.
Okay.
Yes, yes.
Yes,
Now, as soon as you press standby, the timer starts. Okay. Now you have turned the engine. Everything is ready. Suppose pilot delay हो गया and standby is pressed. So after 30 minutes, if after standby, if after 30 minutes engine has not been started, then the first air that will go from here and here, and it will go only to this solenoid valve will activate. First kick. That means only slow turning say आपका pressure will go, okay, and it will open the this what to say slow turning valve, okay. Slow turning valve will be open and you see the line of the slow turning valve will be smaller, okay.
सर एक बार फिर से सर, टाइमर एक्टिवेट आफ्टर दैट.
Hold on. You see this is my auto starting valve, okay. आप यहाँ पे देखो there is a main valve and there is one small line going over here. Can you see? Can you see here?
Yes,
A
sir.
small line,
Yes, sir.
okay, connected
हाँ
to
जी
it,
सर.
okay. And you can see there are two control lines coming through a solenoid valve, which will be over here, present over here. I'll show you here in this part. You can see one valve here, one directional control valve here over here. One is controlling your main starting valve, one is controlling your slow turning valve. Okay. I'll give you much better idea. Okay. Now this is the other दूसरी तरफ से दिखा रहा हूँ आपको. So can you see the line pressure is coming back to the same line itself? The line is connecting back to the same line itself. But you observe the diameter of the pipes. यहाँ पे diameter कितना है? It's smaller as compared to this diameter.
Yes, sir. Yes,
Agreed?
sir.
Yes, sir.
Okay. So when this valve will be opened, okay, same 30 bar is going to be flowing through it. Okay, same 30 bar will be going to flow from it, because right now this solenoid valve is not active, so auto starting valve will not activate. No air will go from this part. Agreed? So air is going to go from this line, which is smaller in diameter. Follow?
Hmm.
So same 30 bar is going here, but the mass of air will be very less, or
Yes,
the
sir.
quantity of air will be less. So when it will go, and this 7 bar is obviously going, it will do the normal part thing. Okay. So same air is going to come over here, but the amount of air that I am going to inject will be very less. Agreed? As compared to your auto starting valve when it will open. So if
Yes, sir.
the amount of air quantity is less, it will turn my engine slow.
Yes, sir.
Okay. Until once it completes one complete revolution. If your engine completes one complete revolution, then this solenoid valve will also be open, and then your engine will start. That means, suppose you are doing maneuvering. Okay, sometime happens you have done maneuvering and you did slow ahead, and then you have stopped your engine, and you have stopped for at least 30 minutes. After that, you gave one more kick, and right now standby is already pressed, isn't it? Standby तो press ही रहेगा maneuvering के time पे. Agreed?
हाँ, sir. Yes, sir.
So after 30 minutes, if you have given one more kick, let's slow ahead. So the first air that goes, it will only go to slow turning valve. Okay, it will only go from here, not from here, because there might be possibilities that in that 30 minutes something might has happened inside my piston and my liner, either water leak or piston has jammed in my liner, or something might has happened. There could be possibilities of 30 minutes stoppage. Okay, so I do
Yes.
not want to give directly 30 bar air. I want to start my engine at a slow RPM. I will give less amount of air. That means my piston will rotate or reciprocate inside my liner slowly. And if it encounters any obstruction, okay, if it encounters any obstruction during this part, this air will not be able to push my piston, and my one complete revolution will not complete. If one complete revolution will not complete within a certain period of time, this will stop. Air will stop and the alarm will come. Okay. And that you have to now find out what is the problem with the engine. Is it clear?
हाँ,
So
sir.
after 30 minutes, what has happened is my air has gone. Okay. After this, that's where I have given. My air will not go. Air will only go to only slow turning valve will go. After the slow turning, one complete revolution has been done. After one complete revolution, solenoid valve for auto starting valve.
सर ये स्लो टर्निंग वाले में भी 7 बार आ रहा है, तो वो भी तो आगे जाके फिर 30 बार ही एक्सप्रेड होगा ना सर, वो कि 7 बार जाएगा वो?
नहीं नहीं, आप समझो 7 bar is only for control purpose. ठीक है, for opening and closing of your valve. You see here in this part, आपको यहाँ पे डायरेक्शनल कंट्रोल वॉल यू विल बी एबल टू सी. कैन यू सी डायरेक्शनल कंट्रोल वॉल 1 and 2? This air is going over here. Agreed? यहाँ पे देख. Okay. So
हाँ सर.
in this part, this is my auto starting valve over here. Okay. Now line pressure is coming, but it is stopping at auto starting valve until it opens, until this air comes. This is open air. This is closed air. Agreed? These are both are coming from directional control valve. Okay. And this open and close is for slow turning valve, the small
Okay,
line.
okay sir.
Okay. So pressure is 30 bar only, but the actuation mechanism is done by the control air to open this valve in order to 30 bar to go further.
ओके
Is
मीन
it
सर
clear?
स्लो के लिए भी 7 स्लो के लिए भी ऊपर जाएगी 7 बार, इसके लिए भी तो जो इसके लिए जाएगी वो ऑटो स्टार्टिंग वॉल्व को खोलेगी, और ये ऑटो स्टार्टिंग वॉल्व ना खोल के वो ऊपर से जाएगी, लेकिन उसका पाइपलाइन जो थिकनेस होगा वो कम होगा सर.
This 7 bar air will come. It will open my slow turning valve. When the slow turning valve is open, the air will follow this path only, not this path. This is closed till now. Suppose 30
यस
minutes
सर.
has happened after you press standby. This is not the valve which is going to open first. Only this valve will be opened first. Air will first go into this valve. It will turn your engine very slow, just like your turning gear. And once the complete revolution has been done, only then this valve will be opened, auto starting valve. And then main line से आपका air जाएगा. Is it understood?
ओके. हाँ जी सर.
Sir,
Anyone has?
after one turn, this slow
Yes.
down valve will be shut off, or it will always will open. Slow turn valve will be closed or will open.
Normally suppose standby आपने press किया and within 30 minutes if you give any kick, both the valves opens. Okay. But if you have waited for 30 minutes, after 30 minutes only slow turning valve will be opened. And once it has done one complete revolution, this will keep in open state only, and this will also open.
ऑटो
And both
स्टार्टिंग
will, yes, and both will close once the fuel has been given.
Okay, sir.
Understood?
Yes, sir.
Okay.
Sir, as the diameter has been reduced,
Yes.
you said the mass of the flow, mass of the air
The
flow.
amount of air will be reduced. Pressure is obviously same, but the amount of air that is getting utilized will be highly reduced. Agreed or not?
Yes,
Air
sir.
कम हो गया ना?
Yes, sir.
Okay. So if air has been reduced, then it will turn your engine slow. Okay. Just like how the turning gear is turning. Okay, little faster than turning gear, obviously, but not as fast as 30 bar से जब दोगे आप. So if any restriction comes, this air will not be able to turn your engine. And for particular time period, if the engine is not completed one revolution, okay, then it will shut off and it will give an alarm.
सर तो मतलब वो 30 बार वो सेम रहेगा.
Pressure will be 30 bar only. That will be going inside, but the amount of air will be less.
Sir,
Okay.
what about the cranking RPM? We will achieve that.
With slow turning, you will not achieve. Okay, slow turning is only a safety purpose, that suppose within that 30 period mark, if you press standby and something has happened inside your engine, you should be able to protect your engine, isn't it?
Yes, sir.
So that is why the slow turning valve is given. Okay, normally it is there on all ships, slow turning valve. Is it clear? ये सब तो देखा होगा आपने. You might have observed this part, ठीक है, on your ship.
Yes, sir.
ठीक है, but इतना नहीं ध्यान से देखा होगा, like how things are happening here, right?
सर
So now
इस
do you
वाल्व के बगल
understand?
में एक और वाल्व होता है सर, वो कौन सा वाल्व रहता
इसके बाद कौन सा valve है?
है?
इसके
इसके
बाद
बगल में था,
non
इसके
return,
बगल में था सर.
this one.
नहीं सर, जो ऊपर से दिखलाया था आपने, पीछे वाला.
This one.
हाँ ये वाला.
This is when suppose you have reached port, then what you are supposed to do is you are supposed to close this valve. When you close this plate will go down. Can you see the part over here? ऐसे आपको दिख रहा है? This will go and interlock it. Hold on, I'll show you some better diagram maybe. So once you close it, this plate is going to go down. Huh? See, right now it is lifted up, and there are few limit switches also. Okay, starting air block आता है एक alarm आपका.
हाँ सर.
हाँ सर.
Okay, so this is that starting air block alarm. Okay, If I'm going to close this wall, this plate will come down and it will not allow any of the walls to open. In case of, किसी से गलती से ही स्टार्ट पे चला गया and starting air is open, air bottle valve is open, so engine will start.
No, sir.
नो सर,
If
अगर
engine
स्टार्टिंग एयर ब्लॉक
control is
नहीं।
in,
Starting
if
will
engine
be
control is in engine room and if your main air bottle valve is open, किसी से गलती से हैंडल चला गया स्टार्ट पे,
हाँ सर हो
what is
जाएगा
going to
सर।
happen? There are possibilities that engine might start.
यस सर।
Okay. Also during doing any work on my main engine, I have to shut this main air starting air block करना पड़ता है हमको. Okay. So what you can see the limit switch is over here. Right now, it is up. Okay. That means I am ready. Obviously, this photograph I've taken when my engine was running. Okay. But if I'm going to go and port, I'm going to close this wall. This plate will come down, pressing this, what do you say, limit switch. Agreed. And this plate will block both the opening of this walls. Okay. If you see, यहाँ पे ऐसे रहता है. When it is
स्टार्टिंग एयर
in,
बंद करते हैं ना सर।
yes, when it is in open position, it will be like this. This is closed position. This is open position. So what happens is you will bring this plate downward. So it will block it. कैसे बनाऊं इसको मैं? ऐसे. Okay. This is, now you will put the plate here. So it will not allow this to go into this position, isn't it?
यस सर।
Open position पे जाने से it will prevent it. Okay, you can see the slot here, and you can see this is air starting wall. This is the pilot air line, 30 bar top. Here in this part you see this one. So can you see here now? If I'm going to close it, it will be interlocked in this part, right? It will not allow my valve to open or close.
यस सर।
Okay, so this is a safety part. Okay, that after you reach port, you have to close this, and alarm will come starting air block. Okay, starting air block का alarm आएगा. You can see there are two switches to monitor it if it is open or closed. Okay, until you open it, the starting air block will not go, and that is an interlock. Okay. Chalo, I'll stop here for today, and tomorrow we will discuss about all the interlocks, why negative cam is given, why engine cannot start on air, why engine cannot start on fuel, your safeties we will discuss, okay, bursting day scan, your flame arrestor and all those things, and we will see how to do certain cross questions regarding it, and then we'll move forward with your distributor part, okay, actual distributor, how it looks like from inside, and what are the different types of distributor do we have, and then we will go for the reversing part. चलेगा?
सर
यस एक चीज। हाँ भाई,
Yes.
पूछ भाई जल्दी।
प्यूरीफायर से सर एक डाउट है सर.
प्यूरीफायर से डाउट है? हाँ, प्यूरीफायर आए